In problem 3, reasoning and properties were used to show that two expressions are equivalent. This is an example of deductive reasoning. Deductive reasoning is the process of reasoning logically from given facts to a conclusion. To show that a statement is not true, find an example for which it's not true. An example showing that a statement is false is a counterexample. You only need one counterexample to prove that a statement is false. Problem 4. Using deductive reasoning and counterexamples. Is the statement true or false? If it is false, give a counterexample. Part A. For all real numbers a and b, a times b equals b plus a. Well, this is false. We can pretty quickly find a counterexample. If we substitute in 5 for a and 3 for b, 5 times 3 is not equivalent to 3 plus 5. So 5 and 3 is a counterexample. Part B. For all real numbers a, b, and c, the quantity a plus b plus c equals b plus the quantity a plus c. Now this should look familiar to us. What's moved are the parentheses or the grouping symbols. This one's true. We can use properties of real numbers to show that the expressions are equivalent. This is simply the commutative property of addition to rewrite the a and b in a different order in the parentheses, followed by the associative property of addition to rewrite as b plus the quantity a plus c. Your turn. A reasoning item. Is each statement in parts a and b true or false? If it's false, give a counterexample. If true, use properties of real numbers, seen earlier in this lesson, to show the expressions are equivalent. Part A. For all real numbers j and k, j times k equals k plus 0 times j. Part B. For all real numbers m and n, m times the quantity n plus 1 equals m times n plus 1. And Part C. Is the statement in Part A of Problem 4 false for every pair of real numbers a and b? Explain.